Hello, welcome to your video on exponential functions. We've been working with exponents. Now we're going to talk about the functions, what they look like, and you will be able to identify, evaluate, and graph them. First thing we need to talk about is what is an exponential function exactly. The easiest thing you can take out of that is the word exponent, because there is an exponent needed in this function. It is in the form of y equals a times b to the x. There is a couple constrictions here. A cannot be 0, and b has to be greater than 0, and b cannot be 1, all for obvious reasons if you just take a second to think about it. Two examples actually, of what these kinds of graphs will look like. I apologize, it's a little bit blurry, but in red you can see y equals 1/2 x will look like this, and then y equals negative 1/2 x will look like the blue line there. How do I identify an exponential function? That's important to be able to do. If you are working with exponents, you have to know if you're dealing with one or not. So the first thing you're going to do, if you're given a table, you're going to find the difference between each of the values. So in this case, as I'm going along, my change in x is just 1. I'm increasing by 1 every time. My change in y is that I am multiplying by 3 each time. And so my consistent difference is a constant ratio. That means it's the same, it's not changing. And because that is true, it's multiplying that's happening there, and not adding or subtracting. That is an exponential function. So yes, this is an exponential function. You might also run into equations, and that is very easy to identify. The form must be in y equals a times b to the x. B has to be a number. X is not a number, so the answer is no. That is not the type of function that it should be written in the form. Your turn. Is this an exponential function? Yes or no, and then give your reasoning. Check in with me when you are done. All right, here is the answer for you. The answer here is no, and if you look, the x values are all adding by 1, and that's normal. But the y values is what's really important, and that's not a constant ratio. We are not multiplying by a constant amount, as you can see, so the answer is no. How do I evaluate an exponential function is the next question. So with that, I'm going to give you an example. Suppose 30 flower beetles are left undisturbed in a warehouse bin. Population doubles each week. The function f of x equals 30 times 2 to the x gives the population after x amount of weeks. How many beetles are there alive after 56 days? The first thing we have to do is just a little bit of conversion. We're talking about x. X is the number of weeks, which is really important because we're talking about days. So we have to convert those 56 days into weeks, and that is going to be 8 weeks. So when I'm solving and using my function, f of x equals, it will be 30 times 2 to the 8th power, and f of x is just a fancy way of saying y, so don't let that confuse you. And then you evaluate this a little bit more, so we have 30 times order of operations. We have to do exponents before we do multiplying, so 256. And last but not least, we multiply that together, and we get the answer of 7,680. So there will be 7,680 beetles after 56 days, which is really gross because that's a lot. Your turn. Please evaluate this equation for x equaling 3, and check in with me when you are done. You should have gotten an answer of 48 for that problem. If you didn't, go back and check your work. Otherwise, ask questions in class. Next question we have to answer is, how do I graph an exponential function? This is a very important skill to be able to do. So when you're given an equation, like you see here, y equals 3 times 2 to the x, you're going to use that to make a table, a little t-chart. And the easiest way to do it is just to pick whatever x values you want. You do need to have some negatives and some positives. Keep it simple. That's what I would recommend at least. So pick easy numbers to work with. And then you're going to evaluate this. So 3 times 2 to the negative 2 power. And that is 3 times 1 over 2 squared. And when you simplify that out, you will get an answer of 3/4. So your coordinate then is going to be -2 3/4. You're going to evaluate again. Showing your work is really important because some of these are not so easy. This one will become 3 times 1 over 2 to the first power, which is just 2. Your coordinate then becomes -1 and then 3/2. 0, so 3 times 0, 3 times 2 to the 0 power will give you 3 times 1, which is just 3. So then my coordinate is 0, 3. Keep going. I'll let you finish it up, so go ahead and do that. You should have gotten coordinates for 1, 6, and then the last one would be 2, 12. Now that you have those coordinates listed, you're going to actually graph next. And how you do that is just normal, how you normally would. Sometimes it's a little bit messier just because you have fractions and things like that. But you just do your best. So -2 3/4, that's going to be something along those lines. And I apologize, it's really hard for me to graph on here. I'll try and make it a little bigger. There we go. And then I have, my next point is -1 3/4, which is a little bit closer. And then I have 0, 3, which is up here. And then 1, 6, which is here. And then 2, 12, and I actually ran out of room. It would be somewhere up here. But that's what your graph looks like if you connect the dots. You'll see it is not a straight line, it is not linear. It is curved, and that is what an exponential graph will always give you, is a smooth curve. How do you write an equation? So sometimes you will be given a graph like you see here, or a table, and this table happens to be for this graph, since some of the numbers are not so nice. And then what you're going to do is just find out what the equation is going to be. You'll want to use 0 will be a helpful piece of information, because 2, if you keep in mind, our formula is y equals a times b to the x. When x is 0, that means b to the 0 power is 1, so it gives you your a number right away when you're using 0. So I automatically know that I have y equals 100. Now I have to figure out what my b is. In order to figure this out, x is going to stay x in this case. So then I figure out what I'm changing by every time. This is obviously one, we've talked about that numerous times. But my change in y is the more important thing. That's going to help me determine what b is. Because whatever that change in y is, as long as it's constant, and it should be because it's exponential, whatever that constant y change is being multiplied by, and yes, it will always be multiplied when it's exponential, is what the letter B is going to be. So I have some easy numbers here that are going to be helpful. Going from 100 to 25. I am decreasing. And if I'm multiplying, and keep in mind, because we have to multiply, you're going to want to think dividing by 4, but we have to multiply it. So multiplying by 2.5 instead. And so we try that again. 25 times 2.5, or sorry, 0.25. That will give me 6.25, and you keep going. It works every time, which means my equation will be y equals 100 times 0.25 to the x power. You could also say y equals 100 times 1/4 to the x power. That would be acceptable also. Just being aware of things that are the same, mean the same, just look different. Your turn. Please graph. You will have to be neat on this one. Graph y equals 0.5, so 1/2 times 3 to the x. Be detailed in this. Be as specific as you can. And we will go over what this graph looks like in class. This is the end of your video. Thank you for watching. Have a great day.